Hello everybody. Today we're going to be doing some vector addition, and we're going to be using the law of sines and cosines to do that. To remind you what the law of sines and cosines are, take a look at this triangle over here. This triangle has interior angles big A, B, and C, and each angle has a corresponding side, which is across from it. So the angle A has a corresponding side length little a, the angle B has a corresponding side length little b, and the same thing with C over here. Now the law of sine states that sine of A divided by little a is equal to sine of B divided by B, which is sine of C divided by C. Now, in order to use the law of sines, you're going to need to have one complete ratio. So you're going to need to know an angle and the side length across from it in order to use this. But also you're going to need one other piece of information. So in total, you're going to need 3 pieces of information. And those 3 pieces of information require you to have a complete ratio of at least one of these quantities. The law of cosines states that a squared equals b squared plus c squared minus 2bc cosine of a. Now, whenever you're trying to solve for a side length, you need to have the corresponding angle that goes with it. So if I want to find c, I need to know a and b, but I also need to know the angle that's across from c. This is the formulation that I'm going to use because it's going to help us a little bit when we're solving for vectors. Now, this over here is how you're going to find the resultant vector when you're adding vectors using this sines and cosines law. The first thing you're going to do is draw the vectors. Then you're going to find the magnitude of c using the law of cosines. And you're going to find the direction of c using the law of sines. Note that the c is the resultant vector of adding 2 vectors a and b, or in other words, that the vector c is equal to a plus b. Let's take a look at an example here of this. Okay, so this question reads, use the sine and cosine law to add the vectors a and b. Before we start, let's write down the givens. The givens are a equals 24 newtons, east 15 degrees south, and b is equal to 65.0 newtons, south 30 degrees east. One thing that I want you guys to notice is that if you take a look at the number of sig figs, a has 2 sig figs, and b has 3 sig figs. So our final answer is going to have 2 significant figures. What are we required to do? We're required to find the vector sum, c, is equal to a plus b. Add the vectors. And we're going to use the sine and cosine law to do that. Taking a look at analysis, the first thing we're going to do is we're going to draw the vectors and find the interior angles of those vectors. So we don't need to be too precise with this, but we do need to be able to draw the vector summation. So the first thing I'm going to do is I'm going to take a look at vector A. I notice it's 24 newtons, so I'm going to draw about 2.4 newtons, or 2.4 centimeters. And we know that it starts off going east and about 15 degrees south. So I'm going to draw a vector that looks kind of like that. So that's 2.4 centimeters. I'll label that as 24 newtons. And if we notice something, this angle right here is 15 degrees. Okay, I'm going to call this side A. And next, we're going to use the tip to tail method. And I'm going to draw the 65 Newton force. It's going to start off going south, and then it's going to go 30 degrees east. So I'll draw something maybe like that. Again, this doesn't have to be too precise, but that'll be our 65 Newton force right there. That'll be the vector B. The angle from the vertical right here, if we draw a straight line, this angle right here is 30 degrees inside, okay? Next, I'm going to draw the resulting vector of the summation of A and B, and that's going to go from the A vector all the way down to the B vector, and that's going to be C. Now, in order to use the law of cosines, and we're going to need to find out the interior angles of this triangle. The first thing I'm going to notice is if I draw a east-west line right here, that intersects this red line at a 90-degree angle right here. So this angle inside is 90 degrees, but that also lets us determine what this angle right here is. This is also going to be 15 degrees. In order to find this out, this is done by using the Z theorem in trigonometry. So I can find the total angle inside by adding up these three angles. So when I go over to my solve step, how do I find the angle C? Well, the angle C is going to be equal to, well, that 15 degrees that we had, plus the 90-degree angle, plus the 30-degree angle, to give us a total sum of 135 degrees. So if you go back to our diagram here, this angle right here is 135 degrees. Great. So this is all the information we need to know in order to use the law of cosines. So let's write down our law of cosines. It says that c squared is equal to a squared plus b squared minus 2ab times the cosine of the big angle C that we just found. That's this 135 right here. If we're going to put in our numbers, we can write c squared is equal to, well, A is 24 newtons squared, plus B is 65 newtons squared, minus 2 times 24 times 65 times the cosine of 135. If we put that into our calculator now, we can find that c squared is going to equal 24 squared plus 65 squared minus 2 times 24 times 65 cosine of 135 degrees. And we're going to find that to be 7,007.173157. But we need to take the square root of this number in order to find c. So we take the square root of the answer. We're going to find that it's equal to 83.7. So c is 83.70, and that looks like it's going to be a 9 newtons. For our answer, we're going to round this off to two significant figures, so that'll be 84 newtons. If you go back to our analysis, we've drawn the vectors, found the interior angles, we found c using the cosine law. Now we need to find the direction of c using the sine law. In order to find the direction of c using the sine law, what we need is one more interior angle of this triangle. It doesn't matter which one we choose, but I'm going to choose this angle right here. I'm going to call that angle B. Okay? So in order to find angle B, excuse me, we need to use the law of sines. Because we have 65 degrees here, we have 83.709 newtons here, we can put that right into our formula for the law of sines. So let's write that down. Sine of B divided by B is going to equal the sine of C divided by C. Putting our numbers into our equation, we'll find sine of B divided by 65 newtons is equal to sine of 135 degrees divided by 83.709. I'm going to put that into our calculator now. We're going to have sine of 135 divided by 83.709, and then we're going to multiply that by 65. And this is going to give us an answer of sine B equals 0.54906. Now we just need to take the inverse sine of this answer, and that'll leave us with an angle of 33.303 degrees. So going back to our diagram, we see that this is 33.303 degrees. Now, this is not going to be the direction of C. The direction of C has to be given with reference to our north, south, east, and west frame of reference. So in order to find the direction of C, we need to find the angle from maybe this vertical component here, or from this horizontal component right here. Okay? Now, if we notice from before, this angle right here, between the blue line and the eastward direction, is 15 degrees, and this angle B between the blue and the green line is 33 degrees. We can find the direction of C by adding up these two numbers. So the angle of C, or the direction of C, is going to be equal to 33.0303 degrees plus 15 degrees. That gives us the angle, or the direction of C, to be 48.303 degrees. Rounding it off to two significant figures, that'll be 48 degrees. Okay? And that's going to be east, 48 degrees south. So, finally, we have the vector C is going to be equal to 84 newtons in the direction of east, 48 degrees south. And this is our final answer right here. Okay? So for our statement, we should write something along the lines of the vector C is 84 newtons east, 48 degrees south. And that's our final answer.